This video shows the progression of power factor or dissipation factor over frequency. Furthermore, measuring transformer winding insulation, including the connection of measuring leads, is explained. A two-winding transformer contains a high-voltage winding and a low-voltage winding. Because of the internal connection, the phases cannot normally be measured separately. Therefore, there are three measurable capacitances: the one from the high-voltage winding to the core, the one between the windings, and the one from the low-voltage winding to the tank. Let's take a look at some examples. This 60 MVA transformer displays a relatively small dissipation factor. These are two identically built transformers, GT1 and GT2. GT1 has lower dissipation factor values than GT2. GT2 displays extremely high dissipation factor values for lower frequencies, especially from the high voltage winding to the tank and between the windings. A transformer like this distribution transformer with 11 kV primary rated voltage and 800 kVA typically has higher dissipation factor values. The power factor or the dissipation factor at 50 Hz is over 1%, and the minimum lies far above 200 Hz. It can be assumed that the insulation contains a relatively large amount of water. If all bushings are connected to each other during a test, we only measure the dielectric losses. Now let's see what happens if we remove this connection. A capacitive current flows through the high voltage winding and the low voltage winding. If the connectors of the high voltage bushings and the low voltage bushings are not connected to each other, current also flows through a second winding. As a result, the core gets magnetized, leading to further losses, which overlay the dielectric losses. These additional losses can create conspicuous effects. If the phases of a winding are not properly connected, or not connected at all, the dissipation factor or the power factor may display a peculiar progression. This curve even displays negative values at around 250 Hz. This is what the curve looks like after the contacts have been cleaned and the bushings were connected to each other. Bad contacts can result in a measured dissipation factor far better than the actual value, which will lead to a completely wrong diagnosis. To make sure that the measurement itself is in order, it is important to record frequency responses.